Hey everybody, so in the prior day lessons, we focused on inequalities, but using the operations addition and subtraction in isolating the variable and solving the inequalities. So today we're moving on to multiplying and dividing. And first I'm going to talk about multiplying and dividing by a positive number on each side of an inequality makes an equivalent inequality. So what you need to know is when you're multiplying and dividing by a positive number with inequalities, you do it just like you would when we've been doing it with equations, okay? So here's an example. So I've got 5y is less than or equal to 10. So I want to isolate y, so I'm going to divide by 5 so that I get 1y is less than or equal to 2, because 10 divided by 5 is 2. So this is my solution set, right? Y is less than or equal to 2 for this inequality to be true, okay? So this is my solution set, and there are like countless possibilities that I could plug in for y to make this inequality true. It just has to be less than or equal to 2. So I'm just going to start kind of real easy and just say, all right, well, 5, and I'm going to plug in the value of 1/2. So 5 times 1/2 would make this, what, 2.5, and 2.5, because I plugged in 0.5 for y, and 0.5 is less than 2. So 2.5 is less than 10. So I know when I substituted 1/2 in for y up here, 5 times 1/2 is 2.5, and that makes this inequality true. It is 2.5 is less than or it's less than 10. So now I'm just going to plug in 1 for y. So I'm going back up here. And is this true? Well, 5 times 1 is 5, right? And 5 is less than 10. So again, that's true. If I go ahead, let's plug in 1.5 for y, right? And it's still less than 2. 5 times 1.5 is what? 7.5. And 7.5 is less than 10, so I know I did that correctly. Let's try 2, because it does have the equal to sign. So y can be equal to 2. So if I plug in 2 for the value of y, well, 5 times 2 is 10, and 10 is less than or equal to 10, so that is true. So as long as I plug in values for y that are less than or equal to 2, my inequality will be correct. Now, if I didn't listen to this solution set and I plugged in 3, well, 5 times 3 is 15, and 15 is not less than or equal to 10. So therefore, that is not correct, plugging in 3 for y. I have to have my y value be less than or equal to 2. So now let's try this with a negative number. As I'm trying to make you a point, I'm going to actually do it, and you're going to see that there's a problem in this method if we use the same approach. So if I use the same approach, I have negative 5y is less than or equal to 10. So just like I did over here, I'm going to divide by my coefficient, right? Except it's going to be negative, because I want to divide a negative by a negative to get a positive. You always want to leave your variable as a positive. So I'm dividing a negative by a negative because that would be a positive 1, which means 1y. If I'm dividing by negative 5 on the left of the inequality, I need to do it on the right of the inequality. So positive 10 divided by negative 5, positive divided by a negative is a negative, and 10 divided by 5 is negative 2. So let's start plugging in solution set. So I need a y that is less than or equal to negative 2. So I am going to plug in negative 3, right? Because negative 3 is less than negative 2, right? It's farther away from 0. So let's find out, is this true? If I go back to this original solution set, negative 5 times negative 3 is positive 15. We get a problem, don't we? Positive 15 is not less than or equal to 10. All right, well, maybe I did something wrong. I'll try it again. All right, I'm going back up here, negative 5. All right, well, I'm going to say, negative 4. Negative 4 is less than, in value, negative 2, right? Because it's a farther away from 0. So I'm going to plug that in and see, does that make it true? Well, negative times a negative is a positive. Well, that's not true. 20 is not less than 10. I have a problem here. All right, well, maybe, what if I just do, well, it could be equal to negative 2. So let me try that. Negative 5 times negative 2. Well, negative 5 times negative 2 is positive 10. So positive 10 is less than or equal to 10. So in this instance, the only one that worked was negative 2 in here because we got a negative times a negative is a positive. But other than that, I could keep substituting negative 5 times negative 5 is less than or equal to 10. Well, negative times a negative is a positive. So we have 25, but we know 25 is not less than or equal to 10. So the lesson here is when you are multiplying and dividing by a negative number, when you divide or multiply by a negative, like here, negative 5 by negative 5, what you have to do is flip the inequality. Flip the order of the inequality. As soon as you divide by a negative, you need to reverse the order of the inequality. So negative 5 divided by negative 5 becomes 1y, and we have 10 divided by negative 5 is negative 2. So y could be greater than or equal to negative 2. So it's the opposite. This said y is less than or equal to negative 2. And this is the correct way to do it because when you are dividing by a negative or multiplying by a negative, you flip the direction of the inequality. So now if I substitute here, my solution, this is my solution set, and it is a correct solution set. So let's just try plugging in. So negative 5, I'm going to pick y that is greater than negative 2. So why don't I just pick negative 1, right? Because negative 1 is greater than negative 2. And let's see if I do this, if it works. So negative 5 times negative 1 is positive 5. Positive 5 is less than 10, so it worked. Let's try another one. Negative 5. Let's go ahead and go with 1/2. Because 1/2 is still greater than negative 2, right? Negative 5 times 1/2 is, a negative times a positive is a negative, negative 2.5. Negative 2.5 is less than 10, right? So back up to this original one. What about if I did negative 5 times negative 2? Well, negative 5 times negative 2 is 10. And 10 is equal to 10. So that is why the negative worked, the negative 2 worked in here because of the equals to line underneath. That was the only number that would have worked with this error. So the lesson is that when you are dividing by a negative, or when you're multiplying or dividing by a negative inequality, you need to flip the inequality in your solution set for your solution set to work with the original inequality. So you don't flip the inequality in the original inequality, how you had it written, but you flip it in your solution set when you're actually solving for the variable. So you leave it alone up here, but you flip it when you are solving for, when you're doing your solution set and solving for the variable. So we're going to do some more practice with these, but I wanted to explain why this works. Most kids just learn, if I'm multiplying and dividing by a negative, I flip the inequality sign. And they just learn that rule, but they don't know why the rule works. So that's why I wanted to show you, with positive numbers, you don't worry about it. You just do it like normal. With negative numbers, if you do it like normal and you don't flip the inequality in your solution set, it's going to be wrong. And then I wanted to show it to you correctly, where when you divide or multiply by a negative number, you flip the inequality when you're solving for the variable so that you can get a solution set that is accurate. Otherwise, your solution set will be incorrect like we had in this middle example. So now we're going to do some on your own.